Welcome to your Algebra 2 Lesson 4.1 and 4.2 on graphing quadratic functions. So the objective is that you will be able to graph quadratic equations, quadratic functions. A quadratic function is a function that can be written in the standard form y equals ax squared plus bx plus c, where a does not equal 0. The graph of a quadratic function is a parabola. And here is what the most basic one looks like. F of x equals x squared is the parent function. You can see here that if you plug in 1 and you square it, 1 squared is 1, so we have the point 1, 1. Here's 2. If we square 2, 2 squared is 4, so the point 2, 4 is also on. And each of these points is reflected across the y-axis, so the y-axis serves as the axis of symmetry. And that is the line x equals 0. The vertex lies on that line. The vertex for y equals x squared, or f of x equals x squared, is 0, 0. It is at the origin. And so that is our parent function. Properties of the graph of y equals ax squared plus bx plus c include the graph opens up if a is greater than 0 and opens down if a is less than 0. So if a is positive, the parabola is positive and it looks like it's smiling at you. If a is negative, the parabola is negative and it looks like it's frowning at you. The graph is narrower than the graph of y equals x squared if the absolute value of a is greater than 1, so things like 2, 3, 4. And it's wider if the absolute value of a is less than 1, so things like 1/2, 1/3. The axis of symmetry is the line x equals negative b over 2a, and you need to write the whole thing or you don't have an equation of a line. Okay, you have to write x equals negative b over 2a, whatever that value is. And the vertex has the x-coordinate of negative b over 2a. So the way we find the y-coordinate is we take that negative b over 2a value and we plug it in to the function and generate our y value. The y-intercept is the point 0, c, because if we plugged in zeros for x's, this term would zero out, this term would zero out, and we just have y equals c. Okay, so we're going to graph the function y equals 2x squared minus 8x plus 6. All right, the first step is to identify the coefficients of the function, the a, b, and c. A is 2, b is negative 8, c is 6. Because a is positive, because it's greater than 0, the parabola is going to be smiling at us. It's going to open up. Step 2, find the vertex. So first we're going to calculate the x-coordinate. We're going to calculate negative b over 2a. So it's negative 8, so positive 8 over 2 times 2. So 2 times 2 is 4, 8 divided by 4 is 2. So the x value of our vertex is 2. Now to find the y-coordinate of the vertex, you just plug in x equals 2 and you figure out what the corresponding y value would be. So we have 2 times 2 squared minus 8 times 2 plus 6, so that is 8 minus 16, which is negative 8, plus 6 is negative 2. So 2, negative 2 is the vertex. And then you want to plot that point. So go ahead and take a second and plot 2, negative 2. Okay, you're going to draw in the axis of symmetry that is going to be that vertical line that runs through the vertex, so x equals 2. So whenever we draw in an axis of symmetry, we use a broken line. So draw a broken line at x equals 2. Identify the y-intercept, 0c, which in this case is the point 0, 6. Plot 0, 6, and then reflect the other point. Okay, so here's where we are. We've got 2, negative 2. We've got x equals 2, which I use a broken line for. They use red, just a different color, but I always use a broken line for axes, like an axis of symmetry, anything like that. So 0, 6, we're at 0, 1, 2, 3, 4, 5, 6. So there's a point there. See how it's 2 units to the left of the axis of symmetry? You just reflect 2 units to the right, and boom, you know that there's another point at 4, 6. So you use your symmetry to help you out. And then step 5, evaluate the function for one more value. Let's see, x equals 1 would be easy to use. So take the 1 and plug it in for x. So y equals 2 times 1 squared minus 8 times 1 plus 6. So it's 2 minus 8, which is negative 6, plus 6 is 0. So the point 1, 0 is on the graph, and then use the reflection. It's 1 unit away from the axis of symmetry, so to go 1 to the other side, to the right side of the axis of symmetry, and plot the point 3, 0 right here. So plot that point. and you should have a pretty good picture of your parabola. And so we would just then draw it in. So here's our 0, 6, our y-intercept and its reflection. Here's 1, 0, and its reflection over here to 3, 0, and our vertex, and we can draw in our parabola. Okay, for y equals ax squared plus bx plus c, the vertex's y-coordinate is the minimum value if it opens up, so if a is positive, if a is greater than 0, and it's the maximum value of the function if a is less than 0. So here you see a is positive, and so there is a minimum y values. The y values get smaller, smaller, smaller until you get to your vertex, then they get bigger, bigger, bigger. So that is going to be the minimum value, the y value is. Over here where you have a being negative, and it opens downward, the y values get bigger, 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 and then you get to the vertex, and then the y values get smaller and smaller and smaller. So that y value is the maximum. So, unless stated otherwise, the domain of a quadratic function is all real numbers. Depending on the sign of a, the range will either be all real numbers greater than or equal to the minimum value, like right here, or all real numbers less than or equal to the maximum value. Tell whether the function 3x squared minus 18x plus 20 has a minimum value or a maximum value, then find the minimum or maximum value, depending on which one it has. Okay, so you look at what a is. A is 3 because a is positive. It opens upward. I always draw like just a little tiny little picture. Okay, it opens up so I can tell it has a minimum value. So that's the first thing we have to tell. All right, it's going to be a minimum value. To find it, you need to calculate the coordinates of the vertex. So x is easy to find first. It's negative b over 2a. And so that's negative 18 over 2 times 3. And so that gives you positive 3. All right, that's the x value. We're interested in the y value. You have to find the x value first and then shoot it through the function, and that'll give you the y value. And so you get y equals 3 times 3 squared minus 18 times 3 plus 20. So that's 27 minus 40, let's see, 54 plus 20. So that's negative 27 plus 20, which is negative 7. Sorry, it took me a second there to think that through. The minimum y value is negative 7. You can check the answer on the graphing calculator if you wish. Okay, you just enter the function into your graphing calculator, go to Analyze, tell it you want to find a minimum, and give it a lower bound and an upper bound, and boom, it'll let you find that minimum value. Okay, so let's look at that. Enter the equation in F1 in the graph portion of your scratch pad. Okay, so go to the graph portion of your scratch pad and enter 3x squared minus 18x plus 20. If you don't have a little prompt for F1 of x, press tab and it'll show up. All right, so here we can see our parabola. We can visually see the minimum, so that's good. We have to be able to see it. So from there, you want to determine visually looking at it whether it's a maximum or a minimum, because you have to tell the calculator that. So this obviously has a minimum there. It goes down and then heads back up, so it's a minimum. Go to the menu, select Analyze Graph and Maximum or Minimum depending on what you need. We need minimum. So your screen should look like this. And so you get a prompt for a lower bound, and you're going to press Enter anywhere to the left of the minimum. So this is fine right here, or I could even come closer to right here. Anywhere, as long as I'm to the left of this point, I can press Enter. And then you're going to be prompted for an upper bound. And so you're going to go to past the minimum to the right of it and press Enter. And then it will give you the point 3, negative 7, and so the minimum value is negative 7. Okay, so I had to adjust my window to see the coordinates. Notice that it's no longer negative 7 point something to 7 point something, but negative 15 to 15. So I just went to Window, and where it tells you can adjust the window, and I manually went in and changed the y minimum to negative 15 and the y maximum to 15. All right, so we've looked at standard form. Now we're going to look at another form, vertex form. Y equals a times x minus h squared plus k. The graph of y equals a times x minus h squared plus k is the parabola y equals ax squared translated horizontally h units and vertically k units. That should seem very familiar, just like with the absolute value functions. The vertex is hk. The axis of symmetry still goes through the x value of the vertex, so it's x equals h. And just like before, the graph opens up if a is positive and it opens down if a is negative. Okay, so we're going to graph y equals negative 1/4 times x plus 2 squared plus 5. All right, so we're going to identify the constants. A is negative 1/4, h is negative 2, and k is 5 because we are in vertex form here. We're not in standard form. The x isn't squared just right there. We have the x squared over here. And then k is 5. Because a is less than 0, this parabola opens down. We're going to plot the vertex hk, negative 2, 5, and draw the axis of symmetry at x equals negative 2. So here we've got our vertex at negative 2, 5. We've got our axis of symmetry at x equals negative 2. We're going to evaluate the function for two values of x. So we let x equal 0, and so we're going to plug in 0 for x. So we've got y equals negative 1/4, 0 plus 2 squared, and then plus 5. 0 plus 2 is 2, squared is 4, times negative 1/4 gives us negative 1, plus 5 is 4. And so we have 1.04. And we have another point. We're going to let x equal 2. 2 plus, and I picked values that would be convenient to actually do the number crunching, but we could have picked any two values we wanted. So I went with x equals 2 here because 2 plus 2 gives me 4, and squared, that gives me 16, times negative 1/4 is negative 4, plus 5 is 1. So we have the point 2, 1. So we're going to plot the point 0, 4 and 2, 1, and then we're going to use the reflections across the axis of symmetry. Okay, here's our axis of symmetry. We're going to plot 0, 4, we're going to plot 2, 1, and then we're going to use the axis of symmetry to actually draw in a couple of other points. So we're going to draw a parabola through the plotted points. So here's 0, 4. We reflect across the axis of symmetry to this point here. So that's what negative 4, 4. And then down here we have 2, 1. And we mirror it across our axis of symmetry to get another point, and then we draw in our parabola. One more form is called intercept form, and we've got y equals a times x minus p times x minus q, and that's called intercept form because p0 and q0 are the x-intercepts, and you can read it straight from the form. The axis of symmetry is halfway between P0 and Q0, so we just take the average. So we do P plus Q divided by 2. And that gives us our axis of symmetry and the x value, the x-coordinate of our vertex. The graph opens up if A is positive and down if A is negative. So we want to graph y equals 2 times x plus 3 times x minus 1. So the first step is identify the x-intercepts. Because p is negative 3, because remember it's x minus p, so it's x minus negative 3. So p is negative 3. And then this is x minus q, so q is just 1. The x-intercepts occur at the points negative 3, 0, and 1, 0. Step 2 is going to be to find the coordinates of the vertex. You're going to do p plus q over 2, so negative 3 plus 1 over 2 is negative 1. To find the y value, you just plug in that value for x into the equation and solve. So we've got y equals 2 times negative 1 plus 3 times negative 1 minus 1. So that's 2 times negative 2, which is negative 8. So negative 1, negative 8 is the point that is the vertex. We're going to draw a parabola through the vertex and the points where the x-intercepts occur. So we have x-intercepts at negative 3, 0, and 1, 0, and we have our vertex here. And let's look at this equation. We're going to use the quadratic function in intercept form. The path of a place-kicked football can be modeled by the function y equals negative 0.026x times x minus 46, where x is the horizontal distance in yards and y is the corresponding height in yards. How far is the football kicked? So that's asking how far does the football go from the place where it's kicked to where it lands? What is that horizontal distance? And then we're asked for the height, so that's asking for the maximum height here, and so that's going to be the y value of our vertex. All right, we want to rewrite the equation, the function as y equals negative 0.026 times x minus 0, so that we can, it just had x, but if we write it as x minus 0, we can see that p is 0, and then q is 46. So you know the x-intercepts are 0 and 46, so you can conclude that the football is kicked a distance of 46 yards, because the distance from 0 to 46 is 46. To find the football's maximum height, calculate the coordinates of the vertex, and it'll be the y value. So x is going to be p plus q over 2, so 0 plus 46 over 2, which is 23. Plug that in, and you get approximately 13.8. So the maximum height is the y-coordinate of the vertex, or about 13.8 yards. All right, we're going to change from intercept form to standard form. So we've got y equals negative 2 times x plus 5 times x minus 8, and we want to write that in standard form. So write the original function, multiply the two binomials using FOIL. Okay, so you're going to have the negative 2 times x squared minus 8x plus 5x minus 40. Combine the like terms, and you'll have negative 2 times x squared minus 3x minus 40. Now distribute the negative 2. And so we get negative 2x squared plus 6x plus 80. So y equals negative 2x squared plus 6x plus 80, and that is in standard form. So you're going to have to know the names of the different forms and what they look like. You have to know the intercept form is where you've got the two binomials multiplied together. The standard form is when everything is simplified. You've got it in ax squared plus bx plus c form. And that vertex form is in the y equals a times x minus h squared plus k form. You've got to know the different forms. We also got to be able to go from vertex form to standard form. So we'll copy the original equation, f of x equals 4 times the quantity x minus 1 squared plus 9. Well, you need to rewrite x minus 1 squared as x minus 1 times x minus 1, and then you got a FOIL. So we're going to have 4 times the quantity x squared minus x minus another x plus 1, and then out to the side plus 9. Simplify inside the parentheses by combining like terms, and you'll have 4 times x squared minus 2x plus 1, and then the plus 9. We're going to distribute the 4 to everything inside the parentheses, and so we get 4x squared minus 8x plus 4, and then we add 9 at the end, and we end up with 4x squared minus 8x plus 13, and that is our function in standard form. It's in ax squared plus bx plus c form. You've got y equals 4x squared minus 8x plus 13. Okay, guys, that is it for this lesson. You need to try the problems to try on your own. If you can't do them, go back and re-watch part of the video or come in and get some help. I will see you in class, and I hope you have a great day.